In this session you will learn how to create a LUKS encrypted volume on Red Hat Enterprise Linux. Before showing you the details, I would like to go over the different steps that are needed to create the encrypted volume. If something often goes wrong when people try to create an encrypted volume is that they mix up the tasks that they need to be performing on the petition level and the tasks that need to be performed on the LUKS encryption level. So in this slide you can see the summary of different tasks that need to be accomplished. First, on the petition level, you need to create a petition. Next, you will need to format the petition as an encrypted device. The command to use for that is script setup lux format dev sdb1, for example. When formatting the encrypted device, you also need to set an encryption password. That password is going to be needed later to open the encrypted device. Now, once you have formatted the encrypted device, you need to open it to make it available to your operating system. So that would be the script setup lux open command. This results in a new device that is created in the dev mapper directory. This dev mapper device takes the name that you have used when using the script setup lux open command. Now, on this dev mapper device, you can create a file system you mounted, and once you stopped working with it, you can close it. Now, this exactly is the level where things often go wrong. What I see too often is that people are doing well up to the step where they need to open the device using script setup lux open on dev sdb whatever, and next they want to create a file system on it, and what they try to do is mkfs.ext4 on dev sdb1. That's so wrong, because when you use mkfs.ext4 on dev sdb1, you are trying to remove the encryption level again, and with the result that you can start all over again. So when working with LUKS encryption, make sure to distinguish between the different tasks that you need to perform on the petition level and the tasks that need to be performed on the LUKS encryption level. So in this slide you have seen the overview. Now let's have a look how to do the different tasks for real. So here we are on the console of a Red Hat server. Before starting to create the encrypted device, I must check if something is available as a disk, as a petition, or as a logical volume. Now, for the purpose of this demonstration, I created a new disk, and I will show you the current layout of this disk. So the name of the disk is dev sdb, and fdisk-cul on dev sdb shows that currently the disk is empty. No partitions are existing yet. Now, for the purpose of this demonstration, I'm going to create one big partition so that we can use it later as the encrypted device. To do that, I'm using fdisk-cu on dev sdb, and then in fdisk starts its interactive part of the setup. The first command to use is n to create a new partition. Then I use p for primary partition, partition number 1. First sector take the default, last sector I also take the default. You have probably done this before, so I'm not going into much detail here. Just want to do p to verify that the partition has been created successfully, and next I'm using w to write the change to the system. Just to be sure, I like to verify in the proc partitions file, which is the kernel perspective of the current partition table. So all the partitions that the kernel currently knows about are shown here. I just want to make sure that I see SDB1 here. I can see SDB1, so we're all good. So I can continue and start setting up my LUKS encrypted device. Now, the master command for setting up LUKS encrypted devices is script setup. Everything you do with regard to LUKS devices, you'll use script setup. So in order to format the device, I'm using script setup lux format on dev sdb1. We get a warning, which is normal, because if you make a mistake here, you can't get your data back later. So that's why I need to type uppercase yes. Next it needs a LUKS passphrase. This passphrase is what is going to be needed every time the encrypted device is going to be opened. So I'm typing something very secure here, and I'm typing the something very secure again. It waits a little bit. That's because it needs to create the encryption layer here, and that involves some calculation. Now, given the fact that the password was pretty simple, this is pretty fast, straightforward procedure. So I have now added the passphrase to the device, so the encrypted device itself is ready. Now, before I'm going to open it, I'm showing you the contents of the dev mapper directory. This interfaces to the device mapper, and this is where, once opened, we are going to see the encrypted device. As you can see, ls only shows some LVM logical volumes here, no encrypted device yet. So I'm good, and I'm going to continue to open the encrypted device using crypt setup, LUKS open on dev sdb1, and when opening it, I need to give it a name as well. So the name I want to use for this device is secret. Now it asks me for the passphrase. So I'm typing my very secret password here. Wait a little bit. And then it doesn't give any prompt. So normally on Linux that means that it is happy and what I ask it to do has succeeded. So let's check in the dev mapper directory, where we can see that we now have a device with the name dev mapper secret. Now the next step is that I need to create a file system on this device. To do that, I'm using mkfs.ext4 on dev mapper secret. And once more, you need to do this on the device you've just opened and made available, and you do absolutely not need to do this on the partition that you've created on your hard disk, because once more, that would wipe all the encryption information you've just created. So I'm typing this command, and then it's just going to write all the ext4 metadata to the device. Now that I've written the metadata to the device, we can open the device like in mounting it. So let's type mount dev mapper secret on /mnt. So when I go to mnt now, I can see that there's a lost and found, which indicate that it's a partition root. And when I type mount, we can see that dev mapper secret has been mounted on the mnt directory. So that's so cool. Let's create a file. Touch my file, which is going to create an empty file on the device. And I'm done working with it. Now imagine that I want to close everything down so that my data is secure. How do we need to proceed for that? Well, first we need to umount the device, and then we need to do a crypt setup LUKS close on the device. So I'm closing dev mapper secret. Should be closed now. I'm verifying on dev mapper that the secret device is gone and my data is secure. So this ends the demo of how to set up an encrypted device. Now, if you want to do this on a server, you might want the encrypted device to appear from fstab as well. So in the next part of this demonstration, I'm going to show what exactly needs to be done to put the encrypted device in the fstab. You have just created an encrypted device. You probably want to use it automatically when booting the server as well. You cannot just put the encrypted device in etc fstab, because if you want to do that, well, the encrypted device won't be there yet. So you need to find a way that automates the crypt setup LUKS open step that you've used in the manual procedure. To do that, you need to create an etc crypt tab file containing 2 or, if you wish, 3 different entries. So the first entry is the name of the encrypted device you are going to create, and the second entry is the name of the partition that is used as the underlying storage for the encrypted device. Now, an optional third entry is that you can put the password in there as well, but that is a pretty bad idea, because why would you want to use encryption anyway? Well, because you want to make sure your data cannot be accessed by anyone who just steals your hard disk. Now imagine that you are going to automate The entering of the password, well, you might just want to do without encryption at all, because your data is just easily accessible for anyone, even if the person in question doesn't even know your password. So that is why in this demo I'm just showing you how to enter the name of the encrypted device and the underlying storage device in the ETC-Crypt tab. That means that your system will stop during the boot process and will ask for the passphrase. And only if you have manually entered the passphrase, it will be able to continue. Now, once you've put this information in ETC-Crypt tab and you have entered the password during the boot process, the next step can be processed, which is the etc-fstab file. In etc-fstab, you just put the name of the encrypted device, the mount point, and all the other different things that you normally would want to put in an etc-fstab file. Now let's find out how that works. So let's see how to set up the files to automate booting with an encrypted device. The first file you need is the etc-crypt tab file. In this file, the first field contains the name of the encrypted device as you want it to appear in the dev mapper directory. And next you specify the name of the underlying storage device. That's all. So we can quit and save this file and add a line to the etc-fstab file. So go to the end of the file, open a new line, and in the first field you put the name of the encrypted device. Next, you enter the name of the directory where you want it to be mounted. And next you put a file system, the mount options, and the options for dump support and automated file system check. That's all for now, so I can save the fstab as well, and we can reboot the system. As I didn't put any password in my etc-crypt tab file during the boot process, the system will stop and prompt for a password. So I will need to enter my password here, and it will continue. So the booting procedure has completed. I opened the LUKS root login already. So let's type mount and find out if the encrypted device is mounted. Ta-da! There it is. As you can see, the encrypted device has automatically been mounted by including the correct files.